Our ultimate goal is to build a predictive model of this complex system we call the Earth's climate, so we can predict what's going to happen as we modify its various components. The temperature record we have only goes back with thermometers about 140 years, and clearly we need much more data. So we turn to climate records in the natural environment in a subject we call paleoclimatology, the study of ancient climates. We have written historical records that go back more than 150 years, of course, but knowing that in 1153 the potato crop in Ireland was good probably means it was a warm growing season, but doesn't tell you much quantitatively about the temperature on the globe at the time. We have a wonderful record in the rings of trees, which extends back now 13,900 years on an annual basis, and we'll describe how that works in a second. We have an even much longer record that goes back extending through the various cycles of the Earth's tilt and orbital change in the ice cores that we drill through the miles-thick ice that lies over Greenland and Antarctica. We can go even further for millions of years by taking cores out of the deep ocean or from deep lake sediments. And finally, of course, we have fossils and rocks that go back nearly to the beginning of the Earth, 4.6 billion years ago. Let's start with trees. And this is a subject, like many subjects in modern science, that Leonardo da Vinci first noted. He said, "Read the history of past seasons in the rings of trees." This is a subject, about 100 years old now, known as dendrochronology. If you've ever seen a tree cut down, you'll know that it has a series of concentric rings. And those rings represent the wood added in each growing season of the tree. So the one in the center was when the tree was planted. The next one out is when the tree was 1 year old, 2 years old, 3 years old, 4 years old, etc. And these rings have different widths and different compositions depending on the growing conditions at the time they were added to the tree. Now, in fact, some trees are extremely old. And the oldest living things on Earth are the bristlecone pines in the high altitude regions of the California-Nevada border and a few other places in the Rocky Mountains. These trees look like cartoon characters of old trees. They're not very big, but they're all gnarled and bent and broken. And if you drill into these trees, you discover that several of them are 5,000 years old. That is, they've been around since 3000 BC. And every year, they add a single layer. And that layer represents the composition of the atmosphere they breathed in and the water they sucked up from the soil. And it represents an absolute calendrical date. The outermost ring is the one that was done last year. The next one in is 2 years ago. The next one in is 3 years ago. And so we have a perfect calendar extending back for thousands of years. Furthermore, some trees, when they die, fall into muddy riverbanks or into bogs, and they get preserved. And so adding all these old trees, dead trees, to the modern but very ancient trees, we have a continuous record that goes back 13,910 years. From that record, we can see, trivially, by looking at it, which rings are fat and which rings are skinny. Fat rings represent good growing seasons. What does that mean? It means you have an early warm spring, and so the leaves come out on the trees early. They maybe have an extra month to produce wood. It's plenty of water, so the tree doesn't run out of water. And it grows in maybe into a late warm fall where the leaves don't fall off the trees till the end of October. That produces a big, fat, thick ring of wood. On the other hand, you might have a year when the spring is very late, it snows in April, the leaves don't come out until the middle of May, and then you have an early frost in October and the leaves fall off the trees, and so it has less time to grow. And or it may be starved for water because you have a very dry summer, and so you get a skinny little ring. More importantly, however, we can go in and take that wood and analyze the isotopes of carbon and oxygen and the other elements in it because the tree is what it eats. The tree eats the carbon dioxide out of the air, and so, for example, the carbon-13 to carbon-12 ratio gives us a measure of the humidity, where the oxygen-18 to oxygen-16 ratio gives us an excellent measure of temperature. We have, therefore, preserved in the rings of trees over the last 13,000 years a record of Earth's temperature, at least at the places where the trees that we study grow, and we've now studied trees from all over the world. So we can use this tree ring temperature record to reconstruct the temperature in a given location over thousands of years. Here's a plot that has the temperature over the last 2,000 years in Northern Europe. You see the fluctuation is from -1 degree of the average to +1 degree of the average. And you see the temperature bounces around a little bit, plus or minus 1/10 or 2/10 of a degree, until about 600 or 700 AD, when it starts to climb and stays systematically above average for several hundred years. The peak occurs around 1000 AD. This is when the Vikings left Norway, went and colonized Iceland, colonized Greenland, and even visited North America. In fact, they had a thriving civilization in Greenland at this time. They imported cows and goats and sheep. They built barns. They even built churches and imported leaded stained glass windows from Europe. There was a thriving civilization there. The winters were still pretty harsh, but the summers were warm enough that they could grow enough grain to store up for the winter and feed their cattle and livestock. Then, however, the temperature started to fall. And when it fell just half a degree, by 12 or 1300, the Vikings abandoned Greenland altogether, and most of their animals died. Just a change of half a degree in a marginal climate like that can lead to disaster. And the temperature continued to fall right into the 1600s, 1700s, 1800s, when we experienced what we call in Northern Europe the Little Ice Age, with the average temperature a full 0.6 of a degree below the long-term average. This is a period when the paintings like this by Heinrich Averkamp were done. People walking on the canals in the winter, skating, building snowmen. This doesn't happen in the Netherlands these days. The canals rarely freeze over, but this was a common occurrence in the 16th, 17th, and 18th century because the average temperature was below normal. Then we see the temperature start to rise, and then beginning around 1800, rise very rapidly till it's a full degree above average, warmer than at any time, as you can see, in the last 2,000 years. That gives us a record over the last thousands of years, but you'll recall that the Earth's orbital parameters change on timescales of tens of thousands to hundreds of thousands of years, so it would be nice to have a record that went back much further in time. And we have such a record in the Greenland and Antarctic ice.